Assalamu alaikum, brothers and sisters. Welcome to the family of Quest. Have you ever wondered how scientists monitor the Earth's water resources from space? Well, they use a technology known as remote sensing, and it's as fascinating as it sounds. Picture this. You're sitting miles above the Earth, observing the blue planet's water bodies, its rivers, lakes and oceans. You're not just looking at them, you're studying them, understanding them, and all this from the comfort of your space station, or more accurately, your computer. Now let's delve deeper into this fascinating world of remote sensing. It's a science that involves observing, measuring, and analyzing the characteristics of objects or areas from a distance, typically from aircraft or satellites. It's like having eyes in the sky, constantly watching and analyzing the Earth's surface. What makes remote sensing particularly important is its ability to monitor global water resources. In a world where water is becoming an increasingly scarce resource, having the ability to monitor it in real time is invaluable. It helps us understand the water cycle, track changes in water bodies, and even predict future water availability. It's like having a crystal ball, only this one is based on science and technology, not magic. And one of the tools that make this possible is the Normalized Difference Water Index, or NDWI. It's a bit of a mouthful, but once you get to know it, you'll see it's not as complicated as it sounds. NDWI is a numerical indicator that uses the visible and near-infrared bands of the electromagnetic spectrum to identify water content in vegetation. It's like a measuring tape, only instead of measuring length or width, it measures water. The beauty of NDWI lies in its simplicity. It takes complex data and boils it down to an easy-to-understand number. A higher NDWI indicates more water content, while a lower NDWI indicates less. It's as simple as that. Understanding NDWI is crucial in the field of remote sensing, as it allows us to map and monitor bodies of water on our planet. So, buckle up as we dive deeper into the world of NDWI in the next part of this series. So what is this NDWI that plays such a crucial role in remote sensing? Well, NDWI stands for Normalized Difference Water Index. It's a numerical indicator that uses the reflectance measurements captured by a satellite to assess the presence of water. In other words, it's like a digital eye in the sky that can see where water is located on the Earth's surface. Let's break it down a bit. The term normalized difference refers to the mathematical calculation used to analyze the data. It's a way of standardizing the differences in reflectance measurements, making it easier to compare results over time and space. Now, what about the water index part? This refers to the fact that the index is specifically designed to detect water. It does this by looking for the unique ways that water absorbs and reflects light, particularly in the green and near-infrared bands of the electromagnetic spectrum. The NDWI values range from -1 to +1. A higher value indicates greater amounts of water. For example, a dry desert area might have an NDWI value close to -1, indicating very little water presence. On the other hand, a lush wetland or lake might have a value close to +1, suggesting a high concentration of water. It's important to note that NDWI doesn't just measure surface water like lakes and rivers, it can also detect moisture in soil and vegetation, making it a versatile tool for studying various aspects of the Earth's water cycle. So why is NDWI so important? Well, water is a fundamental resource for life on Earth. It's essential for agriculture, industry, and ecosystems. By providing a clear picture of where water is distributed and in what quantities, NDWI helps scientists, policymakers, and resource managers make informed decisions about water management. So, in a nutshell, NDWI is a vital tool that uses satellite data to help us understand the distribution of water on Earth. Now that we know what NDWI is, how do we calculate it? Great question. Let's dive right into it. The Normalized Difference Water Index, or NDWI, is calculated using a simple mathematical formula. This formula uses the difference in reflectance of the green and near-infrared bands of satellite imagery. The formula goes like this: NDWI equals the difference of the green and near-infrared reflectance divided by their sum. In other words, it's green minus near-infrared over green plus near-infrared. Now let's break down the significance of each component in this formula. The green band, which is visible light, is highly absorbed by water. This means that areas with a lot of water will have a lower reflectance in the green band. On the other hand, the near-infrared band is highly reflected by water. This means that areas with a lot of water will have a higher reflectance in the near-infrared band. When we subtract the near-infrared reflectance from the green reflectance, we get a number that represents the difference in water content. Areas with more water will have a larger negative difference, while areas with less water will have a smaller negative difference, or even a positive difference. When we divide this difference by the sum of the green and near-infrared reflectance, we normalize the result. This means that the NDWI will always be a number between -1 and 1, regardless of the actual reflectance values. A higher NDWI indicates more water, while a lower NDWI indicates less water. The beauty of this formula is that it's simple, yet powerful. It can be applied to any satellite image, regardless of the time of day, season or weather conditions. This makes it a versatile tool for monitoring water resources on a global scale. Learning to calculate NDWI can empower us to interpret satellite data and understand the Earth's water resources better. So roll up your sleeves and let's get to work on those calculations. So we've calculated NDWI, but where can we apply it? The beauty of the Normalized Difference Water Index, or NDWI, is that its applications are as vast as the ocean, pardon the pun. Let's dive into a few of these. Flood monitoring is one crucial area where NDWI shines. By detecting changes in water bodies, NDWI can provide early warnings for potential flood risks. It helps identify the areas most susceptible to flooding and allows for rapid response actions, saving lives and protecting property. Irrigation management is another realm where NDWI plays a significant role. With NDWI, we can monitor soil moisture levels, which is invaluable for efficient irrigation practices. It enables farmers to use water resources judiciously, reducing waste and ensuring optimal crop growth. In areas where water is scarce, this can be a game changer. Drought assessment is a third application of NDWI. By providing insights into water availability over time, NDWI can help identify areas experiencing drought conditions. This information is vital for implementing mitigation strategies and ensuring water supply for those affected. But the applications of NDWI don't stop there. It's also a powerful tool for studying the effects of climate change on our precious water bodies. For instance, by tracking changes in water levels and temperature, we can gain insights into melting ice caps and rising sea levels. This data is critical for understanding the pace and impact of global warming and for devising strategies to combat its effects. In short, whether it's flood monitoring, irrigation management, drought assessment, or climate change studies, NDWI offers a wealth of information that is indispensable for environmental studies and management. It paints a picture of our planet's water resources, helping us to understand, protect, and manage them better. The applications of NDWI are widespread, making it an essential tool in environmental studies and management. So, the next time you see a body of water, remember there's more than meets the eye, and NDWI helps us see it. Let's quickly recap what we've learned today. We started by introducing the world of remote sensing, paving the way to our main topic, the Normalized Difference Water Index, or NDWI. We've learned that NDWI is a measure that uses satellite imagery to assess water content in vegetation and bodies of water. After grasping the concept, we dived into the calculation of NDWI. We understood that it's derived by subtracting the near-infrared band from the green band, then dividing by their sum. This calculation, though simple, is a powerful tool for water detection. We then explored the applications of NDWI, from identifying water bodies and monitoring their changes to assessing agricultural needs and managing water resources. And with that, we've journeyed from understanding what NDWI is to seeing it in action. Remember, NDWI is more than just a formula. It's a gateway to understanding our planet's water resources from a bird's eye view. Thanks, stay tuned, and don't forget to subscribe our YouTube channel Quest.